Thank you, David. My name is Carmel, and today's topic is microplastics in water, soil and food. And the content of the presentation today, I will give a definition of what are microplastics. I'll then talk about what plastic waste reduction globally and in Australia, and also waste generation in Australia. We'll talk about why are microplastics a problem, and any research gaps, in particular relating to the food chain, pathways into the food chain, and my research focus, which is a poultry case study investigating pathways. And I will touch upon human health effects briefly, and Anyame then will give a presentation on sources of microplastics in agricultural soil, and he will also detail his research in terms of biosolids use. So what are microplastic particles? They are formed in two ways. Firstly, they are deliberately manufactured. For example, microbeads in facial cleansers, products in paint, or they can be the result of degradation of plastic once it is in the environment. So they were made of synthetic polymers from a petroleum base, and they also contain additives such as phthalates, or also known as plasticizers, which give the plastic its functional and structural qualities, which I will talk about a bit later. And the plastic particles have been found in the environment in different shapes. They might be spherical, they might be films, they may be fibres. And although there is no consensus in terms of what are microplastics in terms of their size range, they can generally be defined in terms of microplastics being greater than 1 micrometre up to 5,000 micrometres, 5 millimetres, and nanoplastics, which we're not really mentioning today, not just for the sake of not being too complex today, but basically nanoplastics are smaller in the nanometre range, below 1 micron. The important thing to note here is most of the, a lot of the particles that we're interested in are not visible to the eye. To give you an idea, the width of a human hair is generally between 50 to 70 micron, and a lot of the particles that we're finding in environmental samples are a lot smaller than this, and not visible. So that's a brief overview of what are microplastic particles and where they come from. So, microplastics generated from plastic waste, and you can see here that this graph is showing the rapid rise of, this is plastic production globally, and from 1950, when plastic was commenced commercial production, through to 2019, and you can see that the plastic production rose dramatically over that period of time. So 460 million tonnes was produced in 2019, and in that same year, 353 million tonnes of plastic waste reached its end of life. Interestingly, the plastic is becoming more of a single-use product in packaging and this is driving the the end of life production, which is ending up predominantly in landfill, with 80 to 90% of this plastic waste disposed of into landfill. This is concerning because landfill is not the solution for plastic waste. It allows the waste to filter down into groundwater, into surface water, and distribute through the air. As the plastic in the landfill degrades over time, it releases these small plastic particles into the environment and then potentially into the food chain. And you can see this is an example. This is Australia's plastic waste production for the year 2018 to 19, and Australia sent 2.1 million tonnes of plastic waste to landfill, which is around 81% of all plastic waste used in Australia. So a very small amount, only 19% of plastic waste was recovered, and an area where we could focus our efforts in terms of reducing this plastic waste would be the household waste, which 47% of plastic is produced from domestic households. So what does this mean for the human food chain? This is a very complex diagram, but it is useful in showing the pathways through the food chain. With the plastic waste on land, it potentially can move through the biosphere between land, air and soil. And to give you an example, if washing of laundry produces microfibers, small plastic particles, and these are then treated through the treatment plants, which cannot capture all of the plastic particles, which Anyame will talk about a bit later. And these are deposited into our rivers, which are then deposited into our oceans, and where fish consume these particles, and then potentially humans are ingesting these plastic particles. So the important thing to note here is that we don't really understand the degradation of these small particles in the natural environment in terms of how long they take to degrade, and however, plastic as a material has got a very long life and has been known to degrade over hundreds to 1,000 years. So what we do know is that plastic does degrade over a very long period of time. So hence, during that long degradation process, these particles can move around in the biosphere and potentially into the food chain. So what research has shown so far globally is that microplastic particles are ubiquitous in the environment. They are in air, they are in soil, they are in groundwater and in surface waters, and have been found in the most remote locations such as Antarctica and on remote mountaintops. These are some examples of some of the concentrations that have been found across the world globally. An urban city environment, for example, found 9,000 microplastic particles per cubic metre in ambient air. And surface water and groundwater studies done in Australia, one of the very few studies which have been done, found 25 particles per litre in surface water and 38 particles per litre in groundwater. However, although it seems globally they are ubiquitous in the environment, there is very little known about Australia. There are some considerable research gaps about the Australian environments and concentrations in Australia. So this is an example of the number of studies that have been done globally compared to what's been done in Australia, and we have a severe lack of knowledge in terms of the distribution and the concentration of particles in the Australian environment. So this then leads me to summarise in total why do microplastic particles potentially pose a problem to the food chain, and that is that particles are ubiquitous in the environment. Hence, we have considerable research gaps in terms of Australian concentrations. We have an understanding that they can be transported long distances. How far we don't, in terms of the air, for example, we don't know. Still, lots of research needs to be done in this area. We have got some knowledge in terms of the food chain. We know there's been many studies done, which I'll talk about in a minute, indicating that particles are entering the food chain. However, we don't understand the sources into the food chain, and we don't understand the pathways. We also understand that the plastic particles contain potentially harmful chemicals. However, we don't understand how these may behave within the human body, and we also don't understand how the human body might deal with plastic particles in terms of translocation into tissue, how long these particles may stay in the human body for, how the leaching of these plastic additives may be dealt with the human body, and generally the body's response. So principally, the health effects are not known, but there is an indication that they are in the food chain, and there have been hundreds of studies completed around the world, mostly with packaged foods. And of course, packaging and processing is a source of plastic particles to food. So most of these studies, there's been a lot of variation with the concentrations reported in food. And for example, salt has been found to contain 3,000, in one study, 3,345 particles per kilogram. These are average concentrations. And two studies, for example, with tap water, one study found 440 particles per litre, looking at the largest size microplastics. However, a second study, which also was able to capture the smaller nanoplastic-sized particles, found much higher concentration in tap water of 151,000 particles per litre. So there is a lot of variation. The other thing to note about the food studies in food is that they are mostly packaged, and no studies have really looked at direct sampling from the farm to understand how particles may be entering food on the farm. So there are lots of ways. I mean, I spoke about the plastic cycle in terms of the movement between land and water. So there are lots of ways in which these particles could potentially enter the food chain. This is an example of the soil, the first line, for example, this one on there. So microplastic particles in soil will then potentially be taken up by plants, which there is some research that has shown that plants are taking up particles into the leaves and edible parts of the plant. Then these plants are eaten by animals and obviously then consumed by humans. There are lots of potential pathways into the food chain. The two pathways that Anyame and myself are interested in particular, Anyame is looking at biosolids and wastewater, and biosolids, and then potentially agricultural soil. And I'm interested in the microplastics in water and grain feed on the farm, and how this is ingested by chickens. So that then leads me to discuss my case study, which is my research. So the main questions with my research are, do poultry birds ingest microplastic particles on the farm, and is animal feed and drinking water a source of microplastics for chickens? So the outcome of my research is to quantify the ingestion by poultry, and then develop an engineering solution for reducing the ingestion by poultry, and then ultimately reducing ingestion by humans. This is the first Australian study to look at pathways on the farm, and it eliminates potential processing and packaging as a source, and is solutions-based research to not just identify the problem, but also to provide solutions in eliminating these plastic particles from the farm. And the outcome of my research is also not just isolated to poultry. Potentially it has synergies for other farming activities, livestock, other types of farming activities, so should be relevant to a wide range of activities. Moving on to probably what everyone is interested in is the human health impacts. And really the human health impacts are unknown. There haven't been a lot of studies in terms of sampling from humans, but this is a list of some of the studies where samples have been taken from human tissue, organs, and microplastics have been found in stool and blood, human blood, the brain, placenta, liver, lungs, heart tissue, and reproductive organs. So they're just some examples, a very, very small number of studies that have been done. And when we talk about health effects, one of the concerning things which is raised in the literature is around the additives and plasticizers that are used in plastic, because if these small plastic particles are being ingested, how are these chemicals then leaching out into tissues of animals or humans? And that is not understood. But what we do know is that a review undertaken by UNEP, is the United Nations Environment Programme, reviewed the potential for these plastic-related chemicals to cause harm, and identified that there are 13,000 plasticizers and other chemicals associated with plastics manufacture, and 3,200 of those chemicals are chemicals of potential concern, which means that the toxicity studies that were reviewed found that in animal studies these chemicals have been found to cause neurological disorders, hormonal diseases, respiratory disease, damage to kidneys, metabolic diseases, type 2 diabetes. So a whole range of disorders are associated with these plastic-related chemicals when you look at toxicity studies of mice, and which then leads me to give you a few examples of what has been completed. A study in Australia looked at 1,500 men and found a relationship between the concentration of phthalates, which are your plasticizers, and cardiovascular disease and hypertension. And in another study of bowel cancer patients, they had a higher concentration of plastic particles than non-cancer patients. In another study of cardiac patients, there was a higher concentration of plastic particles in the artery plaque, which they suggested may have a higher risk, produce a higher risk of stroke or death. I must note though that there haven't been a lot of human studies completed trying to find that causal relationship, and that research is still continuing to see if there is any potential health effects, because it's simply unknown. However, there have been a lot of animal studies in terms of dosing studies that have fed microplastics to animals, mice and chickens in particular. And one study, for example, found that chickens that were fed microplastics, it did induce brain hemorrhage, decreased bacterial diversity in the gut, and impaired organ function. Studies that also fed microplastics to mice found the development of metabolic disorders, reduced reproductive function. However, in summary, a review of 133 animal toxicity studies where microplastics were exposed or fed to animals, 117 of the 133 studies all reported adverse health impacts. So whilst research is continuing and there are no causal links made between microplastics and their additives and human health, there is some studies that are coming out and providing some information, but more needs to be done. I'll now pass over to Anyame, who will talk about microplastics in agriculture.
Thank you, Carmel. Thank you for coming. So, my name is Anyame, and I'll be talking about microplastics in agriculture. So, the benefits in the use of microplastics, plastics, extends to agriculture as well. And if you look at this diagram, you can see that there are different sources of microplastics on agricultural soil. And the intention is to use the plastics to aid in bettering the farm activities. So for example, the netting is basically covering the crops with plastic nets to protect it from birds, diseases, as well as insects. But after use, they become waste. They break apart and become part of the soil. That is how microplastics is formed. And you have sources like coming from the fertilizer. So the plastics are used to encapsulate the fertilizer and applied onto agricultural soil. And the purpose of that is to slowly release the nutrients into the soil. So after that, the plastics remains behind, and they break apart, and they become these microplastics in there. So there are several sources, but recent studies realize that agricultural practices, such as the biosolid reuse, as a major source of microplastics. And these biosolids come from the wastewater treatment plants. And plastic mulching also contributes microplastics. And plastic mulching is basically covering the soil with plastic films to control the rate or reduce the rate at which water evaporates out of the soil, and to also control weeds. So This leads to the plastics tearing and degrading, and they become microplastics, and they become part of the soil. And you have irrigation to contribute in some form of microplastics to soil. So wastewater from the wastewater treatment plant is reused for irrigation purposes, as well as the biosolids is also coming in. And then you also have surface water. Carmel mentioned that there's a number of microplastics that has been found in surface waters. So it is drawn for irrigation purposes that also contributes to some form of microplastics contamination. So this leads me into my topic of discussion, and I'm going to discuss how the microplastics get into the wastewater and accumulate in the biosolids and then sent to agricultural soils and applied onto soil. So I'll start by telling you how the microplastics get into the wastewater in the first place. So you see, wastewater comes from our homes, the industries, as well as stormwater. And all these wastewater contains microplastics. And it starts with our homes, where that kind of microplastics in these products, like cosmetics, toothpaste. So we call these the personal care products. So these are products that we use daily, like your shampoos, the soaps that we use, the facial scrubs, and the toothpaste. So they contain primary microplastics. Carmel mentioned in the first slide that these plastics are intentionally manufactured to be micro-sized. And the purpose of that is to add it to these products so that they can enhance the functionality of these products. So for example, they act like exfoliants. So what this means is that they cause this friction when you use it on your face, on your body, and they help remove dead skin. So these products are also known as the rinse-off products, because after using them, you just wash it off in a few minutes. So they become part of the wastewater and then sent to the wastewater treatment plant. So you have glitters we use in the parties, in the cosmetics, you wash them off, they become part of the wastewater. And that is the primary source. In the industrial setting, the wastewater coming from there also contains some form of microplastics. So for instance, the plastics that you use every day were once in the form of plastic pellets. So these are tiny plastic particles that are intentionally made so for easy transportation or export. So when it gets to the industry, they melt it and mold it into the plastics that you know. So wastewater coming from such industries contain these plastic pellets and goes to the wastewater treatment plant and become part of it. So wastewater, stormwater can also carry some microplastics. And these kind of microplastics the stormwater carries is the secondary microplastics. So what secondary microplastics are? They are just plastics, microplastics that comes about when the bigger plastic materials we use every day, like the cups, the food packages, they break apart or they break down to become tiny particles. So these are not intentionally generated, but they come off from the plastic materials that we have. So for example, the tires, we change the tires because they've worn out. So the question is, where do the particles go? Because they are wearing off, so you have to change it. So they wear off on the roads, and you have plastic litter. These are improper disposal of the plastics in the environment. they expose the environmental conditions like long exposure to the sun radiation, and it makes it brittle, and they break apart. They become microplastics in the environment. And during the use of these plastic bottles, food packages, they also break apart. And from our clothing, during laundry, so researchers actually indicated that if you wash just 1 kilogram of clothing, just once, you generate about 700,000 microplastic fibers. That is a lot. So this laundry wastewater carries lots of microplastics, and they become part of the wastewater that heads down to the wastewater treatment plants to be treated. So this leads me to my next slide. So this is a simple diagram that is showing the pathway of the wastewater getting to the wastewater treatment plant and how they get into the biosolids and then to the soil eventually. So this is the stormwater that I spoke about, carrying the the microplastics in the environment, become part of the wastewater, and industry, residential wastewater also become part of it. And then it heads down to the wastewater treatment plants. So the wastewater treatment plant processes is able to remove most of the particles. So they are concentrated in the solid waste, which is further treated to become biosolids and then reused on agricultural soil. And you have some of the particles escaping through the wastewater effluent, because after treating the wastewater coming in, you need to make sure it meets the EPA standards before you release it into the environment. So it's released into rivers and eventually gets to the ocean. So there are two pathways here. So you have microplastics getting into the ocean through the wastewater effluent, and you have it getting into the agricultural soil, that is land, through biosolids. So in this area, that is the ocean, lots of studies has been done, lots of studies. But in this sector, very few studies have been done. So what is known in the ocean, I'll just briefly go over what has been done in the ocean and what has been found. So if you look at the first one, I said extensive studies has been done in coastal waters, including Tasmania. So lots of studies in the ocean has been done, and it has been found that there's lots of microplastics in the ocean and coastal waters in Tasmania as well. So research have indicated that have estimated that the ocean contains about 50 to 75 trillion plastics as well as microplastics. And the interesting thing about this number is that 80% of the microplastics actually comes from land. So yet there's less studies in terms of understanding the microplastics in the land compared to the ocean. Wastewater treatment plants releases this number, that is 4 million particles per day, into the ocean. That is a lot. This is per day. So that is a lot of particles. And in the ocean, there's also studies that has looked into the impact of microplastics on aquatic animals. Lots of research have reported how they impact, they change their feeding behavior, even death. They accumulate into them, they land on our tables, as Carmel described. They can also cause infections in the fishes, so the aquatic animals, and then internal injuries, as well as affect their reproduction rate. But on land, as I mentioned earlier, the story is different. So, you see, the wastewater treatment plant is not the problem, because they are the frontline defenders, I call it, because they are the heroes in the story, because they do not generate microplastics. So we do generate the microplastics, and what they do is to intercept it and concentrate, so they intercept it with other pollutants that, if the wastewater is not available, they get into the environment and cause even major harms. But then they intercept these particles alongside other pollutants, and the operations are heavily regulated by the EPA. So the wastewater treatment plant is able to remove about 70 to 98% of the microplastics that we generate and that comes out from the environment, and concentrate it in the biosolids every day. So some also escape, that is the 2% left, escape to the ocean through the effluent water release. So this 98% is in the biosolids, because the solid waste generated at the wastewater treatment plant is further treated, because it's highly contaminated stuff. So you have to treat it to meet the regulation, the EPA regulation, before you can send it to land and apply. So it's further treated. But unfortunately, the treatment process do not really remove these microplastics. So they end up in there and then contaminate the soil when we send it to for reuse. So the question is, why land application? I mean, why don't we just dispose it off in the landfill or just incinerate it? So the answer is, the landfills, they are filling up, and it's high cost. Because think about it, this waste is generated in tons every day. And if you send this material to the landfill every day, then that is a lot of money. And secondly, the landfills are filling up. So it's either you end up paying more for your waste to be treated, or the landfill fills up and we don't know where to send it. And it is reused in agricultural soil because they contain these nutrients, which is very good for the soil. That is nitrogen and phosphorus. And they also contain some micronutrients that is beneficial for the soil. They also promote circular economy between the wastewater treatment plants and then the agricultural sector. So it's like a cycle. The waste is generated, is treated, and then they make it beneficial for soil. So you end up reducing waste. So incineration is also not an option, because it's not very cost effective. You just burning the waste, burning the biosolids or the sludge, which is not very cost effective because you need lots of energy to do that. And you also risk some different kinds of pollution. So burning it can lead to secondary pollutants that we don't want, that can be released into the atmosphere. Okay. So land application becomes the sustainable routes and best practice. And this mode of disposal of biosolids is practiced across the country, in the United States, across the world, the United States, the UK. Every country sees the land disposal method to be the most sustainable route and best practice. So, although I mentioned that there is limited study in terms of how microplastics impacts the soil, so there are some studies that have looked into the soil that has been receiving biosolids, and this study is an example, one of the studies that was done, and they looked into the concentration of microplastics in agricultural soils that has received long periods of biosolids application. And they realized that the more the biosolids are being applied to the soil, the higher the plastic concentration there. So you can see a very positive correlation between the two. Other studies have looked into how that microplastics impact soil organisms, and others have looked into how it can impact farm productivity and food safety. So if you look at the food safety, the concern is that the microplastics can leach out those plastic additives or chemical additives and contaminate the soil, as well as when they get into the plants, they can leach out these additives, further contaminating the plant. And in terms of productivity, they can impact the plant growth and crops, and then you end up with low production. So example of the soil organism study is on worms. So you see, this study looked into how microplastics impact the soil worms. Because why the worms? Because the worms, they are the best friend of the farmer, and they are very good for the soil. So if you look at this picture here, so that is an imaged worm, and in it is this tiny whitish stuff in here. These are microplastics. So the worm assumes these microplastics to be food. So they end up engulfing it. And they wanted to know the impact of this. And they realized that the more the concentration of microplastics in soil, the lower the worm reproduce. So that means it impacts their reproduction rate, which can heavily affect the soil. Because if you don't have, if you have limited worms in the soil, then you have the fertility of the soil to decreases as well. So other impact on soil is that the microplastics leach out the additives, and they can also absorb onto them other environmental contaminants. So if you look at this picture, it is a magnet trying to attract other contaminants. So that is how the microplastics behave. They can absorb onto them other environmental contaminants like the PFAS, the popularly known PFAS, and then you can even absorb pathogens as well as pharmaceuticals and toxic metals, and they can easily be transported through the soil. So they are like, they can transport other contaminants in soil. And they have been discovered to alter the soil pH and decrease the microbial activity in soil. And they can also reduce the soil compaction and water holding capacity. And the scary part of this is that the microplastics can actually migrate vertically into the soil, threatening groundwater security, which we do not want. So in Australia, which just like any other country, also produces biosolids. And this is the amount that Australia produces, and this is a lot of biosolids. And out of this number, 70% is applied to agricultural soil. So that is almost using all the biosolids for agricultural purposes. And recent studies have looked into estimated how much microplastics is getting into the agricultural soils in Australia, and they estimated up to 19 tons per year. So 19 tons, to put it in perspective, it's like the weight of about 2,794 fully grown African elephants. That is a huge number. So in Australia, regardless of these microplastics entering the agricultural soil, there's still studies in this field are still limited. So impact of these microplastics in soil is not is limited. There's no lots of research looking into this. And if you look at this this diagram here, so this is a study that was done in Australia, and this researcher wanted to know the research gap in terms of microplastic study. So the study reported that in Australia, if you look at this arrow pointing to Australia, the red arrow pointing to Australia, as at the time of this research, only 3 papers had looked into microplastics contamination in biosolids, and none had looked into soil. So there's a huge gap in this field in terms of research. And in Australia, the beautiful heart of in Tasmania, the beautiful heart of Australia, there's no studies. So we don't know what is in the soil. We don't know what is happening. We don't know the extent of contamination. Regardless, the soil receiving about 94% of the biosolids produced. And this 94% is supplied on agricultural soil for the past 10 years. So we don't know how far they've migrated in the soil. We don't know the impact they're having on the crops and stuff like that. And there's also limited studies in finding solutions to remove these microplastics or to better capture them before out of the biosolids or the wastewater before they enter the environment. But so this leads us to the question, what can we do about this situation? So there are some policy solutions that has been targeted to the ocean but can benefit the soil as well. For example, in Australia, there's a ban on microbeads in personal care products that I spoke of, the rinse-off products. So it means that products do not have to add these microbeads or microplastics in these products. And for example, these shampoos and the conditioners, the facial wash, as well as the toothpaste. And you have Australia aiming that by 2030, they are going to phase in microfiber filter for all wash machines to capture the microfibers before the laundry wastewater is released to the wastewater treatment plant. So although it is targeted to reduce the microplastics entering the ocean through wastewater treatment plant, but then it also benefits the biosolids, because the less the microplastics get into the ocean, the less we can find. They tend to appear in the biosolids. UK has drafted a bill on the use of microfiber use. Microfiber filter use for all wash machines. France has already passed it into law. It's going to take effect in 2025, and the EU is just to decide what to do. And in terms of initiatives targeted to soil, Germany is the first to actually implement a cap on the number of microplastics that should be or can be in biosolids derived fertilizers. The EU is also targeting to reduce the number of plastics in composted biosolids for soil by 2026. So it looks like there's still work to be done for this to happen. Other initiatives that can help is maximizing recycling, as well as improving the plastic recycling technologies, so that more plastics can be recycled rather than just disposing them off, and then phasing out the single-use plastics, because almost all our products just in plastics, or they are covered in plastics. And the other thing that we can also do is to redesign our clothing to be more resilient to the washing machine process, so that they do not just disintegrate easily. So although these policies could contribute to reducing a future plastic pollution, but then they do not deal with the current accumulation that we have from the past 70 years. So this leads to us looking into engineering solutions to help control the release of these microplastics into the soil as well as the ocean. So this is my research focus, and I am looking into the extent of microplastics pollution as a result of the biosolid application to agricultural soil in Tasmania. And I'm also studying the microplastics characteristics in the biosolids. And then we use that information to look into developing a technology that can capture the microplastics or remove it from the wastewater or the biosolids itself before releasing it to the agricultural soil. So the key points in this presentation is that the world produces lots of plastics, and it keeps increasing, it's not stopping. And the plastics that we produce shed microplastics. And also these plastics take a very long time to degrade. So they accumulate in the environment. And studies have found microplastics in almost all the food that has been studied. And they also has been found in microplastics that have been found in human tissues and organs. And the other thing about this is that researchers are close to developing a standard method. So what this means is that there's the need for a standard method to analyze microplastics in our everyday products, as well as the water we drink, just as there are standards for analyzing lead or heavy metals or in our waters or in our foods. And the last takeaway is that more research is needed to understand the pollution of microplastics, as well as mitigate their release in the environment. Thank you.